Okay, are you guys all ready for the revelation of your lives?
Yeah.
No.
Okay. Be ready. Get ready. All right, so you need to go to arduino.cc. Since you now have your newfound Arduino Nano. So at arduino.cc, you need to go to the software tab and go into downloads and download the Arduino Ide. It may well be and it's going to be a Windows. It's going to be Windows installer. It's going to be this top one. And you do not have to give them money. I understand you're all very poor. Okay, when you download the Arduino Ide and install it, you will see this thing. Oh, I have a criminy. I already opened one. Yeah, so this looks like frickin' processing, right? Guess why?
It is.
Because it is processing. So this makes learning in here stupid easy, right? Because this is not a similar language. This is the same language. Well, almost at least. It's so close as to be almost identical. So you see here, there's a void setup, and then it does stuff. What does that do?
Some sort of output to what I'm assuming is one of these pens.
Yeah, this thing sets up some stuff, right? This is like your Windows setup. But remember, processing fundamentally draws stuff. What does Arduino do?
Sends signals.
Yeah, Arduino fundamentally turns on and off pins, right? So what Arduino really does, the whole purpose of this software is to program this little tiny computer to do something. And the way that Arduino is going to work is it's going to run the setup thing once whenever you press the restart button, right? So there's a reset button on the Arduino, and what that does is it reruns the setup method. So if your code gets borked, you push the reset button, right? Instead of close the window and open the window again, you just push the reset button.
And it's this button.
And it is the physical button on the Arduino.
No, it's the other button on the Arduino.
That's hella cool.
And then down here, there's a loop method. What is the loop method? Yeah, that's frickin' draw, except of course it's not drawing, it's looping. Right? Same thing, different name. So this is the Blink example program. And the way the Blink example, like what the Blink example program is going to do. Oh, and I modified mine. Let me unmodify mine. Let me just show you how to get it. So if you want to get an example, if you go in Files, there's Examples. And then there's whole messes of examples. You guys all see examples? Lots and lots of examples. I'm going to start with basics, because that's where I'm at. And I'm going to skip a couple of these and do Blink. So of course this... yeah, so I'm going to restart that thing. So I'm going to open Arduino. Because I already had Blink open, and I had modified it. Okay, so this is Blink without any modifications here. Cool. So it's got a setup method, and there's a pin mode thing. And what the pin mode is doing is it's saying, this pin will be used in this way. So this pin is the LED built-in pin. Which is, guess what? The LED that's built in. And in what mode will it be used? Output, which means I'm going to tell it when to go on and off, not ask when is it on and off. Why would you ask when something's on and off? No.
If it was a set signal LED.
How about if you were wondering whether you had pressed a button, right? Then you might check whether the button was on or off. You guys recognize that all a button is a switch, right? All it does is close a thing so pixies can run through it. So this is saying we're going to modify the built-in LED ourselves, not listen to it. And then down here in the loop method, what are we doing in the loop method?
Turning LED built in to high, waiting for 1,000 milliseconds, turning low, waiting for 1,000 milliseconds.
Exactly. So we're going to do turn high. I don't know whether high is on or off, but we're going to turn it to high. Then we're going to wait a second. Then we're going to turn it to low. Then we're going to turn it off. Then we're going to wait a second. Then we're going to do the same thing again. It is. So high and low is on and off. And I suspect that actually the built-in LED is backwards, but it doesn't matter for this, right? You guys see why it doesn't matter? Yeah. I mean, it's going to go through anyway, right? So it's going to be on for a bit, and then off for a bit, and then on for a bit, and then off for a bit, and then on for a bit, and then off for a bit. And that's not actually much different than if it was off for a bit, then on for a bit, then off for a bit, then on for a bit, then off for a bit, then on, right? You all lost track of what the first one I said a long time ago was.
You said on. Yeah, and then on. You said on first.
Yeah, so one of them is on first, and the other one is off first. But you're going to upload this code, and you're not going to be sure when it's working. Does that make sense? Like, one of the little LEDs is going to blink to tell you that it's hearing the computer tell it what to do. And then the next thing it's going to do is start blinking. And you're not going to know when it was blinking because it was listening to the computer and when it's blinking because it's doing the loop thing. So, the other things that you need to know in order to get this to work are, one, you need to look in tools. You need to make sure that you've told it the right board. So the board is the Arduino that you have. You have a Nano, right? But by default, the usual selection is something else. So you need to make sure that the little dot is at Nano so that it's telling it instructions for a Nano and not for something else. This took me a second today. These are cheap knockoffs of Arduinos because that's what happens when you look for something for $3 on Amazon instead of paying the full $5 on Amazon. So they don't work with the ATmega 328P processor. They only work with the old bootloader. So you need to make sure that you change the processor to the old bootloader selection. The bootloader is the process is the code that you're writing onto it. No, bootloader. The bootloader is the way that it runs the setup method through the processor. And these processors have the old bootloader on them because they're cheap knockoffs. The other thing you need to do is look at port. So when you plug this in, right now I have no port. See that? There's no available port. Depending on how your computer is set up, you may have ports available before the Arduino is plugged in. If you have available a port called COM1 before the Arduino is plugged in, what is port COM1 talking to? Anybody? Yeah, probably your mouse or your keyboard. If you try to send Arduino code to the mouse, how will it work?
It won't.
It won't, because your mouse is not designed to listen for Arduino code. It will literally just ignore the instructions. So what you want to do is, before you plug your Arduino in, check what's available in port. There might be a couple options there. And then plug in the Arduino. So I have no options in port. And now if I plug in the Arduino, I now all of a sudden have a COM5 port that I can write to. And then when you're trying to write code to the Arduino, so can you all see that I have one LED light on the Arduino on right now? That LED is the one that's next to the little label power, right? Why is that one next to the label power? Yeah, that's telling you that it's on, right? So then when you want to push this code to the Arduino, you do a verify, which takes a second, and will tell you that the sketch is doable, right? So it didn't kick an error at me. It would kick errors just like the processing IDE would if you had done something wrong in your code. And then if you want to actually write it to the device, you have to push the push to device, right? This is a little bit like the GitHub push button. On here, it's just push on to the Arduino. And it'll say uploading. And then if things went well, it'll say done uploading. And then you'll notice that I have here a blinky thing. You guys all see that? Yes. Winning. And if you wanted to make it blink faster, how would you make it blink faster?
Random 1000.
Sure. Yeah, so why does random work? Basically because it's processing, dude. Like, so you push verify. Verify says we're good. Push upload. Uploading, done uploading. And now I have this strange, random, blinking light.
Thank God for
Cool. And this is amazing. Now I can make things randomly blink. How tremendous.
Is there a way to turn off the default power LED?
I don't know. Good question. Let's try it. So from here on out today, what I want you guys to do is take your Arduino and a cable and a friend and get blink working, and then get blink working with an external LED. Should be noted, hang on, before you go anywhere, it should be noted that when I'm programming Arduinos, I have three things open basically all the time. The three things I have open are the Arduino IDE itself, and then two resources that I feel like I always need. I always seem to need this pinout, and this is my favorite one. I found this by Googling Arduino Nano Pin Out and then picking the one that looked like this. So this is my favorite one. You might want to save this someplace. It's a nice, easy thing. The numbers, the purple numbers, are the numbers for the pins that you're talking about. So if you wanted to change this to be the pin 8, you would put pin 8 in here, and then you would modify pin 8 and pin 8, right? And what that would do is that would, instead of changing the built-in LED, it would change the power on D8 as a pin. You guys cool with this? There's a whole bunch of stuff here, right? Like lots of pins have multiple kind of things. Some of these mean something, some of them don't really matter. For right now, just assume that you need one of the digital pins. So you need a D pin, not an A pin, unless otherwise told by the tutorial. Cool? So the other thing you want open is the tutorials page. So like if you wanted to work on buttons, right, your next thing, I think getting an external LED to work would be a good one. You could look in the blink thing to do that. If you want to look at buttons, you might click button. There's here a setup, like a circuit. This is what I was saying about they often connect the powers and the grounds to power and ground, even though they didn't really have to. So they really could have just gone from the ground to, well, where does the ground actually go? To this side of this resistor or whatever. You guys all kind of good with that? So there's a diagram, and then usually a set of instructions explaining what it's doing, and then a schematic, and then some code. And the code is available directly in the IDE. You don't have to copy and paste this. You just open the examples and grab the one you want to look at. Cool?
Cool.
Questions, deals? Do you want to see what it looks like when an upload fails?
Yes.
Yes.
Okay, so if you say screw up code, right, and push verify, you'll get the usual kind of compiler errors, right? So this one says LED bill was not declared in the scope, which really means, dude, that's not a variable I recognize, right? It should be noted that this is a little bit less useful than the processing one. The processing IDE is, or the processing interface is just a little bit better about errors. And then if you say fixed your code, but screwed up something in here, like you had the wrong board or something, you hit verify and it's like, should be like, cool, dude. Right? Like, cool, verified, check. If you hit upload though, it's gonna do something weird. I don't want to show you the other one because it takes forever. Maybe this one's gonna take forever too. Let me pause this. Okay, so this is obviously the kind of the most annoying thing is that you have to wait for it to kick an error. In this case, I pulled the board, but this will also happen if you don't have, if you lose connectivity with the serial port. It might happen if you try to push code to your mouse. But usually, what it'll do if it tries to push code to your mouse is it'll just sit there for about 5 minutes, and then it'll be like, yeah, it didn't respond. Usually it says something like programmer is not responding. And what that means is the board isn't saying that it received the code because it's a frickin' mouse, right? It ain't paid to listen to that. So this is kind of what it looks like if you get something wrong. If you get something wrong, make sure that you've got the right board, that you've got the right processor. So I'm looking Arduino Nano, and I have the old bootloader, and then I need to make sure that I have a port that makes sense. Cool? Questions? Don't fiddle with any of the other options. There are many more ways for this to be wrong than there are for it to be right.